Hello teachers and friends, so today I would like to demonstrate an experiment about the Hooke law. So this is the setup for the experiment. So we have a retort stand, a ruler, and a spring, and a weight. Okay, first we need to find the initial length of the spring. Okay, at this point the beginning of the spring is 40, and then it is at 32.5 if you could see. So from this we could know that the initial length of the spring is 7.5. Okay, now we put 20 grams or 0.2 Newton to the spring. Okay, now we could count the extension. So okay, so it is at 30.5. So when we subtract it, it's going to be 2.0 from the initial length, 7.5. Okay, and then we add 20 grams more, or so it's going to be 0.4 Newton. Okay, 28.5. So the total length is 11.5 centimeters, or the extension is 4.0 centimeters. Okay, add one more, so it's going to be 0.6 Newton. So it's 26.5. So the total length is 13.5, or the extension is 6 centimeters. We add more, 0.8. So the length is at 24.5. So the length is at 15.5, or the extension is 8 centimeters. So we have 1 Newton. The force is 1 Newton. So it's at 22.5, this mark, and then the extension is 10 centimeters, or the total length is 17.5, and then the last one, 1.2 Newton. So the mark is at 20.5. So the total length is 19.5, or the extension is 12 centimeters. Okay, from this experiment we got this data. So this is the mass, and this is the force, or in Newton. This is in gram. So this is the initial length, 7.5. So as I said, the extension for 0.2 Newton is 2.0. 0.4 Newton, we got 4 centimeters. 0.6 Newton, 6 centimeters. 0.8 Newton, 8 centimeters. 1 Newton, 10 centimeters, and 1.2 Newton, we got 12 centimeters. Okay, so from this data we can plot a graph. So we can see this is a really nice graph, a straight one. So when we could conclude that when the force increases, the extension increases. So the gradient of the graph is the value of k. So underneath it is the formula to find elastic potential force. So it's 1/2 fx, or just find the area under the graph. Or if we have the k but we don't have the f, so we could use this formula, 1/2 kx squared. Okay, so there are four factors that affects the k value. So first one is the thickness of the wire of the spring. Second the diameter of the spring. Third, the arrangement, parallel or series. And the last one is the length of the spring. That's all. Thank you.